Okay, this is topic 2. It's hydrogen. I think my mic is better now. The CA video was very bad. Um, it's hydrogen, oxygen, and air. When it comes to notes, she made notes for air and then notes for hydrogen and oxygen. Okay, it's two separate notes files, huh? Anyways, let's start. I'm gonna start with the hydrogen and oxygen because that's how it goes here. Okay, I'll go quickly over that, what's explained, and then what you call it. I'll go quickly over what's explained in the notes and then the questions. Okay, let's start. Hydrogen. These are very important, the methods of preparation, especially for hydrogen and oxygen, okay, because they come in the CAs and they've come before in the CAs. You need to know what's the difference between the laboratory one and the industrial preparation. In the lab, how do you prepare hydrogen? You guys know when you react an acid and a metal, you form a salt plus hydrogen gas. Remember, metal plus acid gets you salt plus hydrogen gas. Remember this from chapter 3, salt preparation. So basically they use this property of hydrogen to prepare it, and this is in the lab. Okay, because why? It's pretty slow. So let's take a look, read over it. Hydrogen is made by the reaction of a metal and an acid, right? So usually the metal is zinc or magnesium. Why these two metals? Because if you were to use مثلا sodium or potassium, the reaction will be so vigorous, especially those group 1 metals. Okay, so that's why they use zinc or magnesium. Okay, they react with an acid, either HCl or dilute sulfuric acid. Okay, so magnesium plus sulfuric acid, you guys know, gets you the salt plus hydrogen gas, right? And same thing with zinc, you get the salt plus hydrogen gas. Okay, so here's the notes. Why don't they use potassium, sodium, and lithium? Because remember, Canalica meets all zebras first. No person here could argue the reactivity series. K and A meets all zebras first. So basically these here, as well as calcium and lithium, okay, they're very active. Okay, so they react very violently with acid, so it is dangerous to put these metals into an acid, so therefore they don't use it. Although they react and it's very fast and it's better, you don't do it because it's too vigorous. So if you're doing this in a lab, especially next year in 12S, inshallah, all of you make it to 12S. If you're doing a lab in chem, you won't be allowed to mix sodium with an acid because the reaction will be too vigorous. Okay, metals below hydrogen in the reactivity series will not react with dilute acid, obviously, right? The reactivity series, by the way, is Canalica meets all zebras first. No is nickel. Person here could argue. This is how I memorize it, okay? So basically anything under this hydrogen, helium thing, whatever, it's not helium, sorry, hydrogen. Why did I write helium? Helium doesn't react. Anything under this hydrogen won't react. Okay, so copper, silver, gold, and platinum. Okay, these are just notes. Okay, you need to know that the ones they're probably gonna ask in the exam is what? Zinc and magnesium. Okay, so this is in the lab. In the lab, you just react it with an acid. Very easy. However, the industrial preparation, this is the industrial preparation, okay? It's done by reacting methane and steam. Remember, methane is an alkane, and whenever you crack an alkane, you may get hydrogen gas as a byproduct, right? So hydrogen is obtained from methane, which is the natural gas, right? This is in the air chapter. We'll talk about it later. Okay, the hydrocarbon is reacted with steam. So the hydrocarbon is the methane. Remember that when you have alkanes and you subject them to high temperatures in the presence of steam, it's cracked to form an alkene and hydrogen. But methane is the simplest one, so it won't form an alkene. It's just gonna get you hydrogen and carbon dioxide. That's why they use methane. Okay, and you can't crack it. Look at it. Methane is CH4. You can't get ethene. You can't get CH2 when you crack it. So it gets carbon dioxide. This is the reaction over here. Okay. Anyways, forget about the cracking part. Just remember, to get hydrogen gas, methane is broken down to get hydrogen. Okay, they take two H's out of it, and the oxygen part reacts with it to get carbon dioxide. Anyways, this is how it works. This is memorizing. Okay, this is the industrial preparation, so you need to know the difference. If they ask you laboratory preparation, it's reaction with an acid. Industrial preparation, it's the reaction of methane and steam. Type hydrogen as a fuel. Hydrogen can be used directly as a fuel or used in a fuel cell to produce electricity. Hydrogen reacts with oxygen to produce water plus energy. The energy released by the reaction can be used to run a car engine, which is similar to car engines which burn petrol. Okay, so basically you need to know the advantages and disadvantages of this. Okay, so when hydrogen reacts with oxygen, obviously you get water, right? But what's the key part here is that when it does this, it releases some energy as well. So cars and engines, they use this energy. So this is called the hydrogen fuel cell. What are the advantages? Hydrogen can be made from the electrolysis of water. If the electricity used during electrolysis comes from a renewable source, then the hydrogen fuel produced is also renewable, right? So if you can get, where did this take me? So I think the chem regional linked, she linked, I don't know what she did. She linked a hyperlink to another site. I don't know what she's doing. Anyway, to do this reaction, you need hydrogen and oxygen. Oxygen is just found in the air, عادي رواق. But this hydrogen is it's the question mark, okay? So if you can get hydrogen in a renewable way, then this energy will end up being renewable, right? So that's the first advantage. And hydrogen can be produced from a renewable source. The second advantage is it doesn't produce pollution. Why? Because you're only producing water. Water isn't a pollutant, right? So it doesn't pollute. So this reaction doesn't cause pollution. What are the disadvantages? Hydrogen does not contain a lot of energy compared to petrol, obviously, right? So a larger amount of hydrogen is needed to run a similar car. The second is that hydrogen is explosive, and being a gas, it's very difficult to store. It's pretty self-explanatory. And the third, if the hydrogen does not come from a renewable resource, but is made from methane, then the hydrogen fuel cell is not renewable. Remember, نحن hydrogen اتفقنا and you can get it from methane, right? And the reaction with metal. But we don't use this, right? We don't use the reaction with metal. We only do this in the lab. But industrially, how do you get hydrogen? You get it from the breakdown of methane and steam, or the reaction of methane and steam. But you can also get it from the electrolysis of water. But the more common method is this reaction of methane and steam. Is this renewable? No. So most of the time, people are going to get hydrogen from this process. So when they do this reaction is not going to be renewable anymore because this isn't renewable. Okay, so that's the third disadvantage. If it does not come from a renewable resource, but it's made from methane, for example, then the hydrogen fuel produced is not renewable. Okay, so memorize these. I'm sure that the course revision was this. Okay, the course revision, I'm gonna go through it very fast because I don't know what this is صراحة. It wasn't mentioned in the notes and it wasn't taught in class, but she still included it because it's highlighted. So I'm just gonna go over it very fast. Okay, how do you test for the release of hydrogen gas? How do you test for hydrogen? It makes a pop sound when it comes to contact with the splint, right? With a flame, right? What's the equation of lithium with liquid water? شو خص lithium and water? Okay, yeah, metal, you guys, hello, there's a topic 10 for metals, but these metals, okay, react with liquid water. Okay, metal, and you should know that it goes like this: metal plus liquid water to produce metal hydroxide plus hydrogen gas. Okay, this is in topic 10. Lithium with liquid water will look like this: metal plus water to produce metal hydroxide, in this case lithium hydroxide, plus hydrogen, and you just balance. And this is Habel. I don't think you're gonna get asked questions about this. Write the equation of the reaction of magnesium with sulfuric acid. Okay, this is okay. This you need to know this, right? This one, why I think they're asking this is because it produces hydrogen gas. But the one she mentioned in the notes is this one, right? To produce hydrogen, how do you produce hydrogen? Metal plus sulfuric acid or hydrochloric acid. What do you get? Metal plus acid, you get salt plus hydrogen gas, right? So metal plus acid gets you the salt plus hydrogen gas, right? So magnesium with sulfuric acid, this is the method of preparing hydrogen. This is the one you must know this, okay? So magnesium plus sulfuric acid, metal plus acid to produce the salt, MgSO4 plus hydrogen gas. Very simple, okay? You need to know this part B, okay? Write the equation of the reaction of zinc with steam, okay? Again, it should does it produce zinc hydroxide? It doesn't. Zinc oxide, yeah. You should know that there's also, in topic 10, there's reaction of metal hornet with metals with water, okay? In topic 10, you should know that there are the reactivity series. How do I explain this without going into topic 10? I can't. Knalka meets on zebras first. Okay, no person here could argue. Okay, this is the reactivity series. These four react with liquid water. They're reactive enough, they're strong enough to react with liquid water. These and this, but we don't care about this. To react with water, it has to be a gas. Okay. Again, this is all topic 10 stuff, metals. It's also included in the final, so you can get a question like this عادي. But these, you need to know that when they react with steam, it follows this reaction: metal plus water, but steam, because it's going to be a gas because it's steam. To produce, instead of metal hydroxide like it was for these, it's just metal oxide plus hydrogen gas. Okay, so here the reaction of zinc with steam, zinc plus water, since it falls under these four. Okay, this magnesium can also react with water. It's like both. It's like it can react with this and react with this. Okay, zinc plus H2O gas to produce the metal oxide, zinc oxide plus hydrogen gas. Okay, so again, you need to know these, but they're gonna be, I'm gonna stress on them a lot in topic 10 because that's when like they're actually explained. Okay, so here you get it like this. Okay, consider the process of electrolysis. Name the two gases that are produced when brine. What's brine? Brine is electrolyzed. Chlorine gas and hydrogen gas. What's brine? Okay, brine apparently is NaCl. Okay, you can just say NaCl. Why do you have to say brine? Anyway, what are the two gases produced when brine is electrolyzed? Okay, if you remember, it's concentrated, by the way. Brine is concentrated NaCl. If you remember, with electrolysis, you have cathode, anode, right? At the cathode, you take a look. Do you have copper or silver? No. So what's going to be produced at the cathode? Hydrogen gas. Type. Cl. At the anode, you take a look. Do I have Cl, I, or Br? That has to be concentrated. Remember, it has to be concentrated. In this case, yes, because it's brine. Brine is concentrated NaCl. Yes, so what does that mean? At the anode, I'm going to have chlorine gas produced. If you forgot this, it's in the electrolysis chapter 4. Okay? Remember the electrolysis of aqueous solutions. At the cathode, you always have either hydrogen gas being produced or copper/silver. Is there copper/silver here? No. So it's going to produce hydrogen gas. At the anode, you either have, it was either hydrogen or, what was it? Hydrogen or I think water, oxygen. Yeah, it was hydrogen or oxygen. Anyway, it's either hydrogen or oxygen at the anode. What? No. At the anode, it's either oxygen or the gas itself. What gases can be produced? For the cathode, we said it's copper or silver. At the anode, it has to be either Cl, I, or Br. It has to be one of these three, and it has to be concentrated. Since brine is concentrated NaCl, that means you have concentrated chlorine. So will you have oxygen being produced at the anode? No. The chlorine will be stronger and it will be produced at the anode. Okay, this was chapter 4, redox reactions. Okay, I'm not gonna stress too much on it because there's a whole chapter about that. Okay, write the equations for the reaction that takes place at each electrode. Okay, at the cathode, we have hydrogen gas being produced, right? So at the cathode, you guys know, remember red cat? So there's going to be reduction at the cathode, and reduction is gain of electrons. So you have H2O. Here's, I always forget it. you have H2O, it's gonna gain electrons and you're somehow gonna get hydrogen gas. How does this work? Now you don't write it as H2O, you write it like this. You write it as H plus, right? Because it was hydrogen ions in the water. It's gonna gain electrons. So here's the thing, you have two H's here, so you have to put 2 here. So that means I should also put 2 electrons. So it should look something like this, but I don't know what the answer is. Let me see. Yeah, they don't write it as H plus, they write it as H2O. So they write it as H2O. Yeah, and over here they have H minus being produced. Yap. So you can memorize this reaction, by the way, huh? If you want, for the production of hydrogen, you can memorize this reaction مثل ما هي. بس أنا try to understand it يعني. You start with water, you gain electrons because it's a reduction reaction, and you're forming hydrogen gas. What else other than hydrogen is there in water? OH minus. So it just releases the OH minus. Okay, at the anode, you guys know there's oxidation. Oxidation is loss of electrons. You have chlorine being produced. Okay, oxidation is loss of electrons, so you have Cl minus. It's loss of electrons, so you're gonna place the electrons at the end. What do you have being produced? Cl2. Type, okay, it's Cl2 being produced, so you need to have 2 chlorines here. And since you have 2 chlorines, to balance the electrons, you need to have 2 electrons. Okay, I know this isn't the nicest chapter. I can't do much, bro. I'm doing my job. That's to explain. You hate chemistry, I hate chemistry, but come on, guys. It's just one more year to go, and we graduate and leave chemistry forever, unless you're doing medicine. But in my case, maybe only 1 month, since I might not be here next year. So make sure you know this, because I probably will not be explaining this to you next year. Anyways, because you do need the redox stuff for next year. So make sure you know it, huh? I won't be here. I probably won't be explaining it to you next year. Write the equation of the reaction of hydrogen with chlorine. Okay. I'm not even gonna try. I'm just gonna show you the answer. Okay, hydrogen plus chlorine. I guess it's pretty self-explanatory. Yani, you can figure it out. H2 plus Cl2. Okay, to produce. It's kind of obvious it's gonna produce HCl. And when H and Cl combine, what do we get? We get HCl. And to balance it, you just put the 2 here. I think, okay, I looked at the answer, but you can kind of figure it out yourself. Okay. أكيد gas. Okay, type hydrogen reduces lead oxide into lead. Water is produced in the process, right? The equation of this reaction do not include states. What is this, man? What is this? What? Type. In case this comes, which I doubt, hydrogen reduces lead oxide into lead. Okay, when you have yeah. For here, whenever you have something being reduced, and a reducing agent, in this case which is hydrogen, you just react them with each other. Okay, so PbO plus hydrogen. Okay, PbO is being reduced into lead, so they told you, PbO became lead. Type hydrogen is the reducing agent, so where did this oxygen go? Hydrogen stole it, so it becomes H2O. That's exactly how a reduction reaction works. Okay, this is why I'm telling you, all the reduction stuff, you need them, outside of the chapter 4. They ask a lot of questions about it. Anyways, list 3 common uses of hydrogen. Okay, this is the stuff we like to see. Okay, question 1, question 4. This is the stuff you might see in exams. Okay, hydrogen. What do you need hydrogen for? Manufacturing organic compounds. Okay, synthesizing ammonia and hydrogen chloride. Of course, ammonia is NH3, which you guys know is used a lot, like fertilizers and whatever. And hydrogen chloride, which is HCl, which you guys know is also used a lot, and you can't have them without hydrogen. Hardening unsaturated oils to make margarine. Okay, guys, hole, just memorize them in case you see them in a multiple choice. Okay, which of the following is an industrial process for the production of hydrogen? What is the industrial process? Thermal catalytic cracking of long chain alkenes. We said yes, right? That is the industrial process. Electrolysis of acidified water. Yes, we said Also, that's one of the industrial processes. Remember when we were talking about the hydrogen fuel cell? And the reaction between methane and steam, that was actually the one mentioned in the notes. So these three. Which one was the laboratory preparation? The lab preparation, remember, was metal plus acid. Okay. Type. Oxygen. Oxygen is very short. So we're going to go through it very fast. Okay. Oxygen, you should know, has two allotropes, O2 and O3, but you usually see O2. You should know that oxygen constitutes 21% of air by volume and 23% by mass. But this is the statistic that they usually ask for. Okay, 21% of air. How is oxygen prepared? And they ask this a lot. It came in the CA command. Okay, you should know which one is lab, which one's industrial. In the lab, oxygen is prepared in the lab by the catalytic decomposition of hydrogen peroxide using manganese oxide as a catalyst. So hydrogen peroxide is H2O2. When it's broken down, you get water. But what comes out after the water? There's still this one oxygen left over, so it goes as O2. To balance it, you put 2, 2. You should know that it's catalytic, not thermal. Okay? Not thermal, no, because they ask this. Okay? Catalytic decomposition. What is the catalyst? Manganese oxide. ماشي? Very easy. What is the industrial preparation? The industrial preparation is the fractional distillation of liquid air. This is what you should know. Nitrogen with a low boiling point is first evolved, leaving liquid oxygen as a residue at the bottom of the tower. Okay? You should know this. It comes multiple choice. It came in the CA command. Okay? Please don't forget. Okay, so here there's a few questions only. Okay, to which group does oxygen belong? Of course, group 6. Group 16, whatever. Okay, how many valence electrons? 6. How do you test for oxygen? It lights a glowing splint, right? We know this. Okay, you know these in case they come multiple. Write an equation to represent the decomposition of hydrogen peroxide. Okay, you need to know this. How do you decompose hydrogen peroxide? It decomposes into water and oxygen. What is the catalyst? Manganese oxide. Okay, you need to know this. Write an equation to present the reaction of oxygen with NaCa, Mg, and S. This came in the CA in week 11. Okay? So you should know this. It came in the CA. These three. Please know them. Okay? The last one didn't come. No. Yeah, so you can get this or this. This is nicer. We like this one looks nicer. Okay, write two equations to show the complete and incomplete combustion of carbon. Okay, the complete combustion of carbon will obviously get you carbon dioxide. Combustion means reacting with oxygen. Okay, if it's complete, what do you produce? Carbon dioxide. If it's incomplete, what do you produce? Carbon monoxide. That's it. If it's complete combustion of carbon, here's how to do it. Complete combustion of what? Carbon. So you write carbon, and since it's combustion, what am I reacting with? Oxygen. Since it's complete, what am I producing? Carbon dioxide. Is this balanced? Yes, you're done. Like, akid carbon is a solid, oxygen is a gas, and carbon dioxide is also a gas. If it's incomplete combustion of carbon, again carbon, you're reacting it with oxygen, but since it's incomplete, what is it going to produce? CO. To balance it, what do you put? 2 here and a 2 here. As usual, solid, gas, and carbon monoxide is also a gas. Okay? طيب. Where am I now? Question 9. Complete the following table. You need to know this, Kevin. Okay. Carbon dioxide, CaO, la la la. Okay. Carbon dioxide, of course, what? Acidic. CaO, it's a metal, so it's basic. PbO, it's what? Amphoteric. Carbon monoxide, it's neutral, right? Li2O is basic because it's lithium, which is a metal, so it's a basic oxide. Metal oxide is basic. Al2O3 is what? Amphoteric. What are the uses of oxygen in case they ask it? It's used for respiration. What? Yeah, oxygen is used for respiration in the body, and it's produced. What's this? The oxyacetylene flame and the oxyhydrogen. Okay, yeah, I think it's not required for a reason. Let's skip this. طيب, air. هلا air. You need to know the air. Okay. Give the composition of air. I'm gonna go through the notes because it's 4 pages, so she put some stuff that you probably will need to know. Okay, these are the composition of dry air. Nitrogen forms 78%, oxygen forms 21%, noble gases and carbon dioxide form the 1%. So you should know that the 1%, what forms 1%? The noble gases, okay? And carbon dioxide. Okay, separation of nitrogen and oxygen, separation is achieved by the fractional distillation of liquefied air. Okay, you need to know this. CQD 12. Give the composition of air under natural conditions. Which is this? You should know it from the notes. Apparently in the notes the answer is different from the CQD. No, this is what I heard. Yeah, you see, don't follow this, okay? Follow this one here. Okay. Wait, what? No, this isn't the answer. Oh, okay. Like, give the composition of air under natural conditions. This is the answer over here, right? Pretty self-explanatory. 78 nitrogen, 21 oxygen, and the rest is carbon dioxide, water vapor, and noble gases. Type. What are the pollutants? These pollutants, you need to memorize them, okay? Sulfur dioxide comes from the fuels which contain sulfur, right? It's matching. In the exam, it comes matching. Oxides of nitrogen, أكيد from car engines. Carbon monoxide and particles come from the incomplete combustion. That's very easy, right? Incomplete combustion, what do you get? Carbon monoxide. Do you get carbon dioxide from incomplete combustion? No. Where do you get carbon dioxide? From the complete combustion. Okay, so this is how you can know these two. Whenever you see incomplete combustion, carbon monoxide, complete dioxide. Okay, methane comes from decomposition of vegetation and the waste gases from digestion. Actually, when cows excrete and release their wastes, they release methane, and that's actually where methane comes from. Okay, that's how I remember it. Type. What are the effects of each pollutant? You need to know this as well. Sulfur dioxide is a poisonous gas that irritates the respiratory tract, and it should you should know it causes acid rain. Then the sulfur dioxide and the nitrogen oxides, they both cause acid rain. Okay, because this comes in written part. What two gases cause acid rain? Sulfur dioxide and any oxide of nitrogen. Any, you can say nitrogen dioxide, nitrogen monoxide, whatever. What else does the oxide of nitrogen contribute towards? It contributes towards photochemical smog and respiratory problems. Carbon monoxide is a toxic gas. You should know that it binds to the hemoglobin, right? What does it do when it binds to hemoglobin? For those who do bio, it will decrease the oxygen capacity in the body, right? So you should know carbon monoxide, it binds to the hemoglobin instead of the oxygen. Because look, hemoglobin is what carries the oxygen in your body. Okay, it binds to oxygen. Okay, but carbon monoxide looks a lot like oxygen. So when hemoglobin sees carbon monoxide, it's gonna be like, oh, that's oxygen. Let me bind to it. But is it actually oxygen? No, it isn't. So what are you doing to your body? You're reducing the capacity of oxygen in your body. So basically, it's toxic. Okay, so it binds to hemoglobin and reduces the ability of red blood cells to carry oxygen, leading to asphyxiation. It's like emphysema. It basically causes breathlessness. Anyways, particulates. This comes from smoking. For those of you who vape, and for those of you who somehow smoke cigarettes at this age, increased risk of respiratory problems and increased risk of cancer. And no, I think this is pretty self-explanatory. Particulates, again, they come from vapes. You know yourself, I'm not gonna say names. For those of you who vape, particulates is causing an increased risk of cancer. An increased risk of cancer. I'm gonna say one more time. Increased risk of cancer if you vape. Okay, and obviously another increased risk of respiratory problems. Carbon dioxide and methane at higher levels, they cause obviously global warming. Okay, and I think all of you know what global warming is. It causes, oh my god, higher temperature in the climate change, whatever. Okay, so this is the table you must memorize. I don't know if it's here. Oh yeah, it's here as well. Okay, you need to memorize this. Okay, the source and what effect. Okay, if I'm just, you can pause and take a screenshot, go over it. I just went over them now, but you should know this. Okay. Anyway, smog. What is photochemical smog? It occurs mainly in areas that have large numbers of automobiles or cars. Funnily enough, it involves, oh my god, so funny. It involves no smoke or fog. Wow, so funny. It is the result of photochemical reactions between what's a photochemical reaction? This was this was in the written part. Any reaction catalyzed by sunlight. It is the result of photochemical reactions between nitrogen oxides and unburnt hydrocarbons released by automobiles mainly. The reaction produces ozone gas, which is highly toxic. Ozone is O3, nitrogen monoxide to produce nitrogen dioxide, which is branch. So how do you get photochemical smog? Usually, what's the common factor here? the nitrogen oxides. So nitrogen oxides will get you photochemical smog. That's what you need to know. Okay. The resulting smog causes a light brownish coloration of the atmosphere, which, what does it cause? Reduce of visibility. So, by the way, light pollution is from smog. Huh? It causes plant damage, eye irritation, and obviously, like every other gas, it causes respiratory distress. Okay, acid rain. When sulfur dioxide reacts with water in the air, it forms sulfuric acid. And when oxides of nitrogen react with water, they form nitric acid. So now you have acids, and therefore you're gonna get what? Acid rain. So the rain in the air is gonna react with these acids and is gonna get you acid rain. Natural rain is slightly acidic because there's carbon dioxide and it has a pH of 5.5. But acid rain has a pH of 4. So well, what's gonna happen? These 6 points. Corrosion of metal structures when it rains. It damages buildings and art statues. Why? Because acid rain will react with the carbonate and cause the erosion, right? It causes increased acidity of water masses, leading to the death of fish. It washes aluminium into water bodies, which also kills fish. So when it rains, it washes. And when it rains, how can I explain this? This one's pretty self-explanatory because there's acid in the ocean. It's gonna kill the fish. But this one, washing aluminium into water bodies, obviously it's also going to kill fish. Why? Because when you rain and you go into the soil, okay, the rain is going to wash off in the soil and move into bodies of water. And carrying along with it, it's going to carry aluminium and other metals, which will also pollute the water and kill the fish. It damages plants, obviously. I'm not going to explain that. Acid rain enhances the leaching of vital minerals out of the soil, leading to the death of trees. Leaching is what I just explained, okay? When it rains into the soil, okay, the rain will go and protrude into the soil and it's going to infiltrate and it's going to run off all the minerals in the soil and take it into the bodies of water. So the water will be polluted by these minerals and the trees will lose their minerals. So not only are you killing the fish, you're also killing the trees. Okay, all of this is happening because of sulfur dioxide and oxides of nitrogen. You need to know these. Okay, why? They ask why more than what happens. Okay, they care a lot about why it happens. Okay, why does it happen? Sulfur dioxide, oxides of nitrogen. Decreasing emission of air pollutants causing acid rain is not easy. One, it's expensive, and the rain most often falls in areas further away from where the gases were emitted. Okay. Carbon dioxide, greenhouse gases, and global warming. Okay. Carbon dioxide and methane are the greenhouse gases. Okay, you should know this. Global warming is the increase in Earth's temperature. The rise in temperature effect. You can pause and read this if you want, huh? Okay, yeah, I'm not gonna read that. Okay, the greenhouse effect. The temperature of our planet is a result of the balance between the amount of heat it receives during the day from the sun and the amount of heat it releases out at night into space. During the day, this is how it works. You need to know this. During the day, energy from the sun reaches the earth in the form of radiation, okay? The surface temperature rises during the day, right? That's why it's hotter during the day. At night, this, like let's say this is our earth and this is the sun, okay, whatever. It releases EM radiation, okay? It goes onto the earth. This is our earth. Okay, whatever. In the day. However, during the night, this EM radiation should be released back into space. Okay? It's released back into the space in the form of infrared. But what's the problem? You have gases like carbon dioxide and methane that absorb this infrared. So they don't allow all of the infrared to leave and escape back into space. So it causes some infrared to be held back on our Earth's atmosphere. And what happens when you have infrared held back? It's gonna cause the planet not to fully cool down. We're doing all this, we're releasing it back into space, so our planet cools back down. But when you have some infrared left over, your planet won't cool down fully. Okay, so that's how global warming happens. So these gases, they absorb this radiation that should have been reflected back in space. Okay, and they trap it in the Earth's atmosphere. The more gases that you have in the atmosphere that absorb this radiation, the more heat is trapped, and therefore there's less thermal energy that's released back into space at night, and therefore the overall effect is that the Earth will receive more heat than it loses, and the temperature will rise. Pretty easy, it's not that hard. Okay, oxides of nitrogen, we already kind of touched on this. When fuel burns in car engine cylinders, a huge amount of energy is produced, which increases temperature and pressure tremendously. Under these elevated temperature pressure conditions, oxygen and nitrogen gases react, forming NO. Okay, memorize this. Again, there's nothing for me to explain, but you should know the oxides of nitrogen, where do they come from? They come from the car engine. The car engine has high pressure, high temperature, so that's how you get NO and NO2. Okay, reducing the effect of air pollutants. What are the strategies to reduce climate change? These, you need to know them. Planting more trees, reducing farming of livestock, because like I told you, the cows, they're the ones releasing the methane. We don't want that. Decreasing the use of fossil fuels by alternative energy sources like hydrogen and renewable fuels like wind and solar and whatever. What are strategies to reduce acid rain? Remember, acid rain is caused by sulfur dioxide. So if you want to reduce acid rain, you need to reduce sulfur dioxide. So this is, you need to know this. The flue gas desulfurization system. Power stations and factories are being fitted with flue gas desulfurization system. What is this? Okay, basically it's a system that removes sulfur dioxide, nitrogen oxides and particulates from the flue gases. These systems have something called a lime scrubber. What does the lime scrubber do? It's an acid. It's CaO. It acts as a base. What happens when you have a base and SO2? مش SO2 it's acidic, right? مش CaO it's basic. So what will the lime scrubber do? It's gonna act as a base, and when it sees the SO2, it's gonna react with it and form a solid that can just be cleaned. You can wash this off and clean it. You see how it works? They're fitted with things called lime scrubbers, which is CaO, calcium oxide, that acts as a base, which reacts with the sulfur dioxide and also the nitrogen dioxide, which is the other pollutant which causes acid rain, and therefore forms a salt that can be easily washed off. Like this, you would have eliminated the sulfur dioxide and nitrogen dioxide from the air, and therefore you would have reduced the risk of acid rain. Also, you can use fuels that have a lower sulfur content. There's also something called the catalytic converter. Since the early 1990s, car exhausts have been fitted with catalytic converters. What's a catalytic converter? They use something called a transition metals, which we're gonna talk about in topic 10. The transition metals such as rhodium, palladium, and platinum to convert harmful emissions into less harmful substances. These transition metals, it's explained here. They are used to help minimize the release of carbon monoxide, oxides of nitrogen, and hydrocarbons. This was actually in the PISA one time. Okay, so catalytic converters are used to help minimize the release of the following gases. Carbon monoxide, how? It converts into carbon dioxide. Oxides of nitrogen are converted into just nitrogen, and hydrocarbons are converted into carbon dioxide and water. So remember, we don't like carbon monoxide because it kills us, it binds to our hemoglobin. We don't like oxides of nitrogen because it causes acid rain, and we don't like hydrocarbons because it causes global warming. Hydrocarbons in methane. Okay, we don't want this. Okay. The typical reactions are this: carbon monoxide, it's oxidized to form carbon dioxide, and the nitrogen monoxide is converted into nitrogen, and the nitrogen dioxide is converted into nitrogen as well, and the hydrocarbons are converted into carbon dioxide. Like this, we would have eliminated hydrocarbons, we would have eliminated carbon monoxides, and the nitrogen oxides. I know it's a lot of memorizing, but you just have to keep on reading over it, and you're gonna get it. Catalytic converters have a large surface area and work best at a high temperature. This is how the catalytic converter looks. Basically, the oxide of nitrogen, carbon monoxide, or unburnt hydrocarbon goes through it, okay, through the catalysts. Remember the transition metals, rhodium, platinum, palladium, okay? You just need to know that the catalyst is a transition metal. If you don't know which one, just open the periodic table and choose one, okay, to form less harmful gases to the atmosphere, okay? You just need to know the general idea. You don't need to know the reactions one by one. Note, the catalytic converters are poisonous in the presence of lead. We don't want lead. Okay, the last thing, photosynthesis. It's the process by which plants make their own food. How does it work? You absorb carbon dioxide. It has to be in the presence of chlorophyll, right? And you need to have sunlight energy. So this is called a what? A photochemical reaction, in case they ask it. Okay? It produces glucose and oxygen. This is pretty, I'm not gonna explain this. Respiration is just the opposite. You burn it in the presence of oxygen to produce carbon dioxide and water and energy. Okay, you need to know photosynthesis is endothermic because you're absorbing energy, but respiration is exothermic because you're releasing energy. Hey, بنكون خلصنا topic 2 air. Oh, do we do the tops? Let me see. Yeah, صراحة I think we should do these tops. Whoa, that's a lot. Whoa, that's a lot. Oh my god. Okay, oh my god. Okay, yeah, I think you should do the tops صراحة. Because these could come in the written. I think it will come in the written صراحة. The blow apparatus includes a glass tube containing copper powder connected to syringe A, holding 80 centimeters cube of air, and empty syringe B. You need to know that the tube containing copper is heated while pushing A's and B's plungers for several times until the copper turns black. At the end of the experiment, the remaining gas mixture is collected in syringe A. Which diagram shows the amount of gas remaining in syringe A at the end of the experiment, knowing that the copper is in excess? طيب, when you're heating something and it turns black, what type of reaction is this? This is what? Combustion. So when you're heating air, that means you're forming في gases, there's some gases, there's some oxygen playing into a factor, right? When you you're heating it and it turns black, this is a combustion reaction. So what gas are you working with when you have a combustion reaction? Oxygen, right? طيب, here's the thing. You're gonna say, طب وليد, how on earth am I supposed to figure out how much gas there is? They just gave me 80 centimeter cube of air. طيب, you have 80 centimeters cube of air, and you know it's undergoing a combustion reaction. So what gas are you talking about when you have a combustion reaction? Oxygen gas. You're gonna tell me, Waleed, they did not mention oxygen gas anywhere here. طب, okay, in air, how much oxygen do you have? This is like where I told you need to know the statistic that 21% of air is oxygen. So you take 21%, 0.21 of 80 centimeters cube, and you get 16.8, so around 16 centimeter cube of air. So let's take a look. Okay. It's correct. What I did was correct, but I have to do 80 minus this answer. Why? The answer is going to be 64, around 63, whatever. It's going to be 64. But why? Because look here, it's 20%. Don't use 21%, by the way. Anyway, why? Because they're asking about the gas remaining in syringe A. So what's remaining in syringe A? Everything other than oxygen. Right? Because اتفقنا the oxygen reacted. So what's going to be left? Everything other than oxygen. So اتفقنا انه 16 centimeter cube of oxygen reacted. So how much is left remaining in the syringe? 80 minus the 16 that reacted or whatever, and you get 63.2. If you use 20%, it's going to be more precise. So use 20%, huh? So this is how much reacted. So subtract it, you're going to have 64 left over. So therefore the answer is D. Okay? Please pay attention to the question. What is remaining in syringe A, not what is gone to syringe B. If they asked what went to syringe B, then it will be 16. طيب. Clean air is a mixture of gases containing oxygen, nitrogen, carbon dioxide, and argon gases. Okay, which gas makes up 78%? Of course, nitrogen, right? We اتفقنا 78% is nitrogen. طيب. Liquids and gases are separated from the mixture based on the difference in their boiling points. Name the technique to separate the components of air. Fractional distillation of liquefied air, right? If you're separating it according to its boiling point. Many pollutants like oxides of sulfur and nitrogen are formed from burning fossil fuels. Write the chemical formula for the sulfur containing air pollutants. What sulfur contains air pollutants? SO2, right? Sulfur dioxide, right? Why is the gas containing sulfur considered an air pollutant? What does sulfur dioxide contribute to? It contributes towards acid rain, right? For formation of acid rain. Suggest a method to reduce the gas containing sulfur from emissions of power stations and name the chemical used. How do we reduce acid rain and SO2? How do we use it? Remember, we used the lime scrubber. Okay? We used the lime scrubber. And the lime scrubber, what's this process called? It's called flue gas desulfurization, something like this. Let's flue gas desulfurization. And what is the chemical used? Lime. If you say just slaked lime, or if you say CaO, because slaked lime is CaO. Remember, it was CaO. If you say that, that's correct. Adi, slaked lime. But nobody uses. Was it calcium hydroxide or calcium oxide? Well, I remember it being calcium oxide. here calcium, yeah, calcium oxide, not calcium hydroxide, but calcium hydroxide works as well. Okay, so calcium oxide, calcium hydroxide, slaked lime, whatever you want to say. Okay, عادي, that doesn't matter. Okay, catalytic converters are installed in exhausts of modern cars to absorb pollutants like oxide of nitrogen, carbon monoxide, and unburnt hydrocarbons. Name two oxides of nitrogen formed in car engines. What are the two oxides of nitrogen? Carbon monoxide and carbon dioxide. It's not carbon, sorry, nitrogen. Nitrogen monoxide and nitrogen dioxide. Very easy, right? These are the two ones, NO and NO2. These are the two nitrogen oxide that are formed in car engines. Carbon monoxide is formed from the incomplete combustion of hydrocarbons like butane, C4H10. Write the equation for the incomplete combustion of butane. Okay, incomplete combustion. I told you, if you want to write incomplete combustion of anything, how do you do it? When it's combustion, what does it mean? It means you're reacting with oxygen. If it's incomplete, what am I producing? CO. So if I'm producing CO, CO and the byproduct is always water, right? Since it's incomplete, am I producing CO or CO2? CO. This is why I put CO, because they said incomplete, huh? Remember, combustion always produces water as a byproduct, okay? So here, and then you need to balance it. C4, so you should put 4 here, okay? So you have 4, 1, you have H10, so you should put a 5 here. So 4 plus 5, 9, so put 9 over 2 here, okay? عادي, yeah. And if you want to multiply the whole equation by 2 to get rid of the fraction, that's fine. Come in. Okay. Triple I. What is the role of transition metals found in the catalytic converters? Remember, I told you the transition metals are the catalysts. They're the ones that facilitate this reaction. They act as the catalyst in the catalytic converters. Rhodium, palladium, and platinum. Carbon dioxide gas is absorbed from the atmosphere by dissolving in oceans, and another natural process X involving plants. How do plants absorb CO2? In what process? Photosynthesis, right? Type. What is they say write the equation? Okay, very easy. For photosynthesis, it's carbon dioxide plus water, right? The plant absorbs them in the presence of chlorophyll, and plus sunlight, right? To produce glucose with C6H12O6 and oxygen, right? Now to balance, and I have it memorized, it's 666 from the amount of times I've seen this reaction in biology. So you can memorize it as well. But if you don't want to memorize, you can try balancing yourself, but you're going to end up with 666, except the C6H12O6, it already has a 6 in the carbons, okay? Name two processes, one natural and one artificial, responsible for the emission of carbon dioxide into the atmosphere. Obviously, the natural one is respiration, right? Now we release carbon dioxide when we breathe, and cellular respiration. And the artificial one is the burning of fossil fuels, right? Combustion of fuels. Okay, carbohydrates are polymers that break down by hydrolysis. Name the simplest product of the hydrolysis of the carbohydrate starch. You should not know this. It's biology. It's glucose, but you shouldn't know it. Okay, and state two ways to break down carbohydrates. You need to use an enzyme or the acid. This is one method, presence of acid and heating it, and the other method is presence of enzyme. And then partial hydrolysis gives a mixture of sugars. Suggest a method to identify. Anytime they ask you to identify a mixture of like sugars or amino acids or whatever, you use chromatography with a locating agent. Okay. 16. Rainwater is said to be slightly acidic due to the presence. By the way, this is part F. I don't think you'll get something like this. Rainwater is said to be slightly acidic due to the presence of carbon dioxide dissolved in it. The word equation showing the acidity of acid rain is carbon dioxide plus water to produce carbonic acid. The acidity of acid rain is due to other pollutant gases. What is the acid formed when sulfur dioxide reacts with water? Obviously, sulfuric acid, right? H2SO4. Okay, is that the answer? Yeah, sulfuric acid, H2SO4. Name another pollutant gas that leads to the formation of acid rain. What did we say? Sulfuric acid, and what? The other gas is what? Nitrogen oxides. Okay? And what acid does nitrogen oxides form? In case they ask it, nitric oxide. Nitric acid, which is H and O3, if they ask it. Okay? So nitrogen oxides, anything. Um, Describe two consequences of acid rain. Obviously, اتفقنا one of them was erosion and the other one was harming, polluting water. See, these are all correct, okay? You can read if you want. Okay, 17. The diagram shows a limestone column in an industrial town. Limestone is largely calcium carbonate, okay? And it's the column when first built, and this is the same column after 40 years. Describe and explain the changes to the column over 40 years. And your answer referred to the change in limestone, the name of a pollutant causing this change, and the chemistry involved in this change. I'm just going to show you the answer key, and we'll go through it one by one. Okay. Okay, that's a lot. So what happened to the limestone? Obviously, it got eroded, right? That's the first thing. Okay, so the change to the limestone, it became eroded. Okay. This was part of the consequences of acid rain. Remember, we said acid rain, it reacts with the carbonate in limestone, okay, and it damages them. Okay, remember when we said it erodes buildings and stuff? Because it reacts with the limestone. Okay, so what's happening here? The change in the limestone, whenever you see limestone eroding like this could come, well, this could come. Whenever you see limestone eroding like this, it's because you say أول شيء is being eroded. Why? Because the sulfur forming sulfur dioxide formed acid rain, okay, and it reacted with the limestone to decompose it. Whatever, this works as well if you want, okay. But the main part here, it was mentioned in the notes. Carbon dioxide. Oh no, over here. Here, yeah. Okay, so acid rain reacts with carbonate in limestone, leading to the erosion of the stone buildings and statues. Okay, so you need to know the change. Okay, refer to the change. It got eroded. What's the name of the pollutant that caused this change? Sulfur dioxide, which became sulfuric acid and dissolved in the acid rain, which caused it to erode, right? What's the chemistry involved in this change? I just said it now. Okay, so the name is sulfur dioxide as the pollutant. The change was erosion. The chemistry involved is this. Okay, which reacts with carbonate in the limestone. Okay, that is the chemistry behind it. Okay, for question 18, by the way, guys, I'd understand why or how, you'd be struggling with this chapter, and it's a lot to take in. But really, the course division, I think the only important thing until now were the tops. And if you were to do anything, it would be grid 12 and 13, these two. Okay, and these tops, صراحة, they're the only important ones. Instead the rest. The notes, just the notes is what matters. Okay. Nowadays, hydrogen is being used as a fuel cell. Petrol that is used as fuel for cars is a major source of air pollution. This pollution can be reduced using the reaction below. What is being happened here? Carbon monoxide plus nitrogen monoxide to produce nitrogen and carbon dioxide. So see, they got rid of the nitrogen monoxide. So where in the car does this reaction take place? And what causes this to happen? In the catalytic converter. Right? Anytime you see in a car pollution being reduced, it's because of the catalytic converter. How is carbon monoxide formed in the car engine? Because I'm going to show you the answers. I'm not sure if my answer is correct, but I think because of by the incomplete combustion of petrol in the car. Okay, how do you get carbon monoxide in nature? How do we get carbon monoxide? We get carbon monoxide by incomplete combustion. So anytime you see how do you get carbon monoxide? Incomplete combustion. That's it. Why does the hydrogen powered car produce less pollution? Because water is the only product, right? In a hydrogen fuel cell, hydrogen used as fuel does not produce pollution because the only product is water. There you go. We're done topic 2. Thank you so much for watching and good luck.